Have you ever looked up at the night sky? Have you ever felt a sense of wonder, a feeling of connection to those distant, shimmering points of light? It's a feeling that has captivated humanity for millennia. We have told stories about the stars. We have navigated our world by them. We have looked to them for answers about our place in the vast, dark expanse of the universe. But what if I told you that the connection you feel is more than just a feeling? What if I told you it is a physical, tangible reality? A truth written not just in the stars, but in every cell of your body. The story I want to tell you is perhaps the most extraordinary story of all. It is the story of you. But it does not begin on Earth. This story begins billions of years ago, in a place of unimaginable heat and pressure. It begins inside the fiery heart of a star. Every single atom that makes up your body, the carbon in your skin, the nitrogen in your DNA, the oxygen you breathe, was forged in the core of a star that lived and died long before our sun was even born. This isn't poetry. It isn't a metaphor. It is the literal scientific truth. The universe is not something separate from us, a distant spectacle to be observed from afar. We are the universe, experiencing itself. The iron in your blood, which carries life-giving oxygen to every part of you, was created in the final, violent moments of a massive star's life. The calcium in your bones, giving you structure and strength, was born in the same cosmic crucible. So when you look up at the stars tonight, I want you to see them differently. Don't just see them as distant suns. See them as your cosmic ancestors. Let's think about what you are made of. If we were to break you down into your most fundamental components, we would find a collection of atoms, mostly oxygen, carbon, and hydrogen, a little bit of nitrogen, a sprinkle of calcium, a dash of phosphorus. These are the building blocks of life. They are the ingredients that come together to form your muscles, your bones, your thoughts, your dreams. But where did these ingredients come from? The universe, in its earliest moments after the Big Bang, was incredibly simple. It contained only the lightest elements, hydrogen, a bit of helium, and a tiny trace of lithium. The rich chemical tapestry we see around us today, the very stuff that makes our world possible, simply did not exist. The universe was a blank canvas, waiting for its artists to arrive. Those artists were the stars. Stars are immense cosmic furnaces. For billions of years, they have been taking the simple hydrogen and helium from the early universe, and through a process of nuclear fusion, have been cooking them into heavier, more complex elements. It is a slow, patient act of creation, playing out on a galactic scale. Deep within their cores, where temperatures reach millions of degrees, stars are the factories of the cosmos. Our story begins not with a bang, but with a whisper. It starts in the vast, cold, and dark spaces between the stars. Here, giant clouds of gas and dust drift silently through the galaxy. These clouds are immense, stretching for light years across space. They are known as molecular clouds, or more poetically, stellar nurseries. They are the birthplaces of stars. For millions of years, these clouds can remain dormant, a placid mixture of mostly hydrogen gas and tiny dust grains. They are the raw material of creation, waiting for a trigger, a cosmic nudge to begin their transformation. Whatever the cause, a region within the cloud begins to collapse. Gravity, the quiet and relentless force of the universe, starts to pull the gas and dust inward. As a clump of gas and dust collapses, it begins to spin. Just like a skater pulling in their arms to spin faster, the cloud spins more rapidly as it shrinks. This rotation flattens the clump into a spinning disk, with a dense, hot ball of gas forming at its center. This central ball is called a protostar. It is not yet a true star, as the fires of nuclear fusion have not yet been lit in its core. But it is getting hotter and hotter. Inside the heart of the protostar, a battle is raging. The core temperature climbs past 1 million degrees, then 5 million, then 10 million degrees Celsius. This is the magic number, the point at which the universe holds its breath. This is the moment of ignition. This is nuclear fusion. To truly understand a star, you must see it as a living, breathing entity. It is engaged in a constant titanic struggle, a cosmic duel between two of the universe's most powerful forces. On one side, you have gravity. On the other side, you have the force of nuclear fusion. For most of a star's life, these two forces are in a perfect, delicate balance. This state is called hydrostatic equilibrium. This balance is what allows a star like our Sun to remain stable for billions of years. But this balance cannot last forever. The star's core is a finite resource. The hydrogen fuel that powers the fusion engine will eventually begin to run low, and when it does, the delicate balance will be broken. The star will start to change. Let us return to the heart of a young, stable star, like our Sun. Here in the core, the process of stellar alchemy begins its first, most fundamental step. The star is mostly hydrogen, the simplest element, and its core is a cauldron of protons seething at 15 million degrees Celsius. Under this immense pressure and heat, the universe performs its most common and vital magic trick, turning hydrogen into helium. The star has successfully taken 4 hydrogen nuclei and forged them into one helium nucleus. For billions of years, a star like our Sun will happily fuse hydrogen into helium, but eventually, the hydrogen in the core begins to run out. In the searing heat of the red giant's core, 3 helium nuclei come together to form a single nucleus of carbon. This is, without exaggeration, one of the most important moments in the history of the cosmos. Once the star has mastered the art of creating carbon, a whole new world of possibilities opens up. The star can now begin to build even heavier elements by a process called alpha capture. It starts by fusing a carbon-12 nucleus with another helium nucleus, an alpha particle. This process continues, like climbing a ladder 2 rungs at a time. As a massive star approaches the end of its life, it develops a truly remarkable structure. It becomes like a cosmic onion. The star has become a series of concentric shells, each one fusing a different element. It is a perfectly organized element factory. The star's journey up the periodic table has been a story of creation and energy release. But this process cannot go on forever. There is a fundamental limit, a final barrier in the universe's great construction project. That barrier is the element iron. Once the star's core is composed of iron, it has reached a dead end. Its internal engine can no longer generate the outward pressure needed to counteract gravity. For stars more than 8 times the mass of our Sun, the end is not a gentle fade. It's actually a cataclysm of unimaginable violence. When the mass of this iron core reaches about 1.4 times the mass of our Sun, gravity overwhelms all other forces. In less than a single second, it shrinks down to a ball of matter just a few dozen kilometers across. As the core collapses, it overshoots its equilibrium point and bounces. It hits a point of maximum density and then rebounds, sending a powerful shockwave outwards. The shockwave hits the star's surface and the star explodes. This is a core collapse supernova. In a brilliant flash, the star becomes billions of times brighter than it was. For a few weeks, a single supernova can outshine its entire host galaxy. All the elements the star so patiently forged during its life are blasted out into space at incredible speeds. We have seen how stars can fuse elements up to iron, but what about all the elements heavier than iron? Where do gold, silver, platinum, lead, and uranium come from? The answer lies in the extreme conditions of the supernova explosion itself. This process is called neutron capture, and it's actually responsible for creating more than half of all the elements heavier than iron. During the supernova, the density of free neutrons is immense. A nucleus can rapidly capture one neutron after another, becoming progressively heavier and more unstable. This is called the R process, for rapid neutron capture. Once the supernova explosion subsides, these highly unstable, neutron-rich nuclei begin to decay. Through a cascade of these decays, the unstable nuclei settle down into the stable, heavy elements that we know. The gold in a wedding ring, the silver in a photograph, the uranium that powers nuclear reactors. Every single atom of these precious and heavy elements was forged in the heart of a supernova explosion. So when you hold a piece of gold, you are holding something that was born in one of the most energetic and spectacular events in the cosmos. You are holding true, unadulterated stardust. The supernova explosion is over. The massive star is gone, leaving behind either a dense neutron star or a black hole. But its legacy is now scattered across a vast region of space. This enriched material drifts through the galaxy for millions of years, carried on the slow currents of interstellar space. The galaxy is a grand cosmic recycling plant. The deaths of stars are not endings, but crucial steps in a continuous cycle of renewal. Over time, this process repeats itself across the galaxy. Generations of stars are born, live their lives, and die, each one adding its own unique contribution to the galactic mixture. Our sun is not a first-generation star. It is the child of countless stars that lived and died before it, a beneficiary of this long cosmic history of enrichment. Every atom heavier than hydrogen and helium that exists today has been through this cycle at least once. About 5 billion years ago, in a quiet corner of the Milky Way galaxy, a new chapter began. A vast cold cloud of gas and dust, enriched by the remnants of previous stellar generations, started to collapse. Surrounding the young, newly ignited sun was a vast rotating disk of leftover gas and dust. This was the protoplanetary disk. For millions of years, this disk was a chaotic place. Tiny dust grains, each one a microscopic piece of stardust, began to stick together through electrostatic forces. They formed larger clumps, which in turn collided and merged to form pebble-sized objects. These pebbles grew into rocks, the rocks into boulders, and the boulders into kilometer-wide planetesimals. The inner part of the disk, closer to the hot young sun, was where the heavier, rocky materials could condense. Elements like iron, silicon, and oxygen came together to form the terrestrial planets. Further out, in the colder regions of the disk, lighter elements could coalesce around rocky cores to form the gas giants. Our young Earth was born from this process of accretion, a molten ball of rock and metal built from the constant collision of planetesimals. The heaviest element, iron, forged in the cores of massive stars and scattered by supernovae, sank to the center to form our planet's core. This created Earth's magnetic field, a vital shield that protects the surface. The water that fills our oceans and makes life possible also has a cosmic origin. Much of it was likely delivered later by comets and asteroids, and so the stage was set. We had a rocky planet, at just the right distance from its stable star for liquid water to exist on its surface. All the necessary ingredients, forged in stars and delivered to this one small world, were now present. From this rich primordial soup, the first simple life emerged. Over billions of years, through the process of evolution, it grew more complex, eventually leading to the vast diversity of life we see today. We have traveled on an extraordinary journey together, a journey that began in the vast cold clouds between the stars, descended into the fiery hearts of stellar furnaces, and witnessed the cataclysmic explosions of supernovae. This story, the story of stellar alchemy, is not just a tale about distant objects in the night sky. It is the most intimate and personal story there is. It is the story of where you came from. It is the scientific, literal truth that you are made of stardust. Every part of you has a cosmic history. The iron in your blood, which carries life-giving oxygen to your brain, was created in the unimaginable heat and pressure of a supernova explosion that lit up its galaxy millions of years ago. You are not just living on Earth, you are Earth, and Earth is a child of the stars. The universe is not a cold, empty void separate from us. We are a part of it. We are the universe experiencing itself. We are stardust given the gift of consciousness. So what does this mean for us? What do we do with this knowledge? For me, it fills me with an immense sense of wonder and humility. It connects me not just to the stars, but to every living thing on this planet. We are, as far as we know, the only beings in this vast universe who can look up and understand this story. We are the universe's way of knowing itself. The atoms in our brains, forged in stars, have been arranged in such a way that they can comprehend the stars. I invite you to step outside tonight. Look up at the dark, star-filled sky, see those distant points of light not as strangers but as your ancestors. You are not separate from this magnificent vision. You are woven into its very fabric. You are stardust, and you are home.